Okay, so again, section in 4.4, arcsine, arccosine, and arctangent. And we've already talked about arccosine in the last chapter. It's the same as before. It's not anything different. But we're going to expand on it and define arcsine and arctangent as well. And it starts with 3 pictures. So if I have my coordinates, and I want to look at cosine, sine, and tangents, and I have just a general rotation, so a general angle. Just like on the daily 2, if I wanted the same cosine value over here, what quadrant am I going to rotate that angle into? Where's it going to go? To the left, right, down? Which quadrant? 4. Goes into quadrant 4. All right, so if we label everything. Because cosine is my u value, I have the same u value if I go down. All right? And if I keep this in terms of theta, that would be a positive rotation of theta, and that's a negative rotation of theta. Those are going to give me the same cosine value. Are they going to give me the same sine value? No. But they give me the same cosine value. All right, for sine, since it's my v value, I go into the second quadrant. So this is the same y value. Flipping it over, that's the same same sine value. It would be opposite cosine values. So if that's theta, and that's theta, if I have this in terms of pi, what's my standard position angle right there? On the warm-up, how we do it was 60, and then we took 60 away from 180. If I'm talking in terms of radian, instead of 180 degrees, what do I have? Pi. So that is going to be pi minus theta. So if I plug in theta, some value for theta, let's say it was 30 degrees, and then pi over 6, plug it into pi minus pi over 6, I'm going to get the same output because of that picture. All right. Tangent is a little bit more complicated because it's the ratio, right, of v over u. So in quadrant 1 right here, it's positive. There's only one other quadrant where I'm going to get a positive value back. Yeah, let's go. 3. So instead of going a rotation down or into quadrant 2, I have to flip it all the way over into quadrant 3. So what angular rotation is that? How much did I have to rotate it by to flip it down there? 180 or pi. All right. So all we're doing is figuring out for any given angle where the 2 values for each sine, cosine, and tangent curves are. Are we okay with these pictures? Yes? Okay. All right. So here's our pictures for sine and cosine. So we define this thing called Arccosine from before, which is all the angles. And in the book, we're now calling A the argument. So in this case, it would be our ratio. So the argument is the thing that you put into the inverse. And this is the same as before. Theta is cosine inverse of whatever ratio that is, plus 2 pi n. And then I also have the negative from my negative angle. And why we use this one before, it's nice because I can combine them into plus or minus cosine inverse plus 2 pi n. Because all that's different about them is one is positive, one is negative. So it's the easiest to remember. It's not going to be the same thing for sine. Because I don't have that nice, easy relationship of 60 degrees and negative 60 degrees. But we can still do it. Okay, so this is my first angle, right? What's the next angle that I have to plug in to get the same sine value? Minus 180, right? Or, right, I'd have pi minus theta equals this, and I switch it around, and I get theta equals pi minus sine inverse plus 2 pi n. Now, I can't combine those with a nice plus or minus because they're not just opposites of each other. This one has the pi minus the first one in there. But that is our definition for arcsine. All right? So instead of plus or minus, I figure out the one that's positive, and then I do pi minus all of those angles to get the other one, the quadrant 2 angles. All right. Last one is tangent. So again, this flips into quadrant 3, and then arctangent is tangent inverse of A plus pi n. And that's it. Why don't I have something that looks like an or a plus or minus? Yeah.
Is it an equivalent value every pi rotation instead of 2 pi rotation?
Perfect. Remember, what's the period for tangent?
180.
Pi, 180, right? Not 2 pi. So I don't need as much information to get a full period. So if I know this angle, I know the next one's just going to be plus pi, the next one's going to be plus pi, the next one's going to be plus pi. So if I have that angle, which is the inverse, I just add rotations of pi. So that one's not too bad. The hardest one is sine, arcsine, because you have 2 distinct equations that you're looking for. Okay, so we just need the one. And then the book starts introducing some notation here that we want to be familiar with. When you get into college, if you take math classes in college, you'll see this a lot, which is a little bit funky to start with, but you just have to read it. You have to interpret what it says. All right, anybody want to take a guess at what that means? Daniel.
The second part is like all of x can be all real numbers.
Very close. So this script R is a set of real numbers. Good. What do the squiggly brackets mean? What's that? It's a set. Yep, it's the set. This vertical line here means such that. So if you were to read this, you're looking at the set of x such that x is an element of the real numbers. So what is a value for x that works with this set? 3, perfect. Any others? 1, great. 2, yeah. How about the negatives? Negative 1's good. What about a half? No? Okay, we're going to step back for a second. What are the natural numbers? All the positive whole numbers. So the ones that you can naturally see, right? You have 10 fingers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All of those, the positive integers are the natural number. What are the integers? What's that? And 0. Good. What are the rationals? The fractions. What are the irrationals? What do you mean by non-fractions? Square root 2, right? All the decimals that don't repeat and don't end. What are the real numbers? Everything, so the real numbers is the bigger set of the irrationals, rationals, natural numbers, integers, everything so far. And then the last one, the complex or imaginary numbers, right? And that's the biggest set. All right, if you are a real number, are you a complex number? Yes or no? All right. Who can give me a complex number, an imaginary number? I is an imaginary number. What's that stand for? Negative 1, right? So 3 plus 2i, is that a complex number? Yes. A plus bi is our general form of a complex number. If b equals 0, then you get a, which is the real number. So in our Venn diagram, complex is everything. Then it goes reals, then it goes irrationals and rationals and integers and then natural numbers. Okay, that's the total aside, but we should know what those are because if it says in the book something is an element of the integers, we need to know what that means. All right? Okay, so that's our set notation. What does this fancy E stand for again? Element. So x is an element of this interval. Okay, so I have an interval from 0 to pi. This is our closed bracket, which means you can equal 0. What do you think the parentheses means? If the bracket is closed, then the parentheses are probably open. All right, which means you can get as close as you want to pi, but you can't actually equal it. All right, way back when you were doing this in 6th and 7th grade and you put it on a number line, it looks like this. All right, open circle, and then I have a closed circle at 0. So what this is saying is x is some number within that interval. So x could be 1, x could be 2, x could be 1.5, x could be square root of 2. Anything in there except for pi. You can get all the way up to pi. So what this is going to look like is I want to find the solutions in a specified interval. And given theta is arcsine, 0.6, and I want to know the values within this interval. So the closed interval from 0 to 360. So what's the smallest angle that I can have? What's the biggest? 360. Anything in there is fair game. Anything outside of that I don't need. So what we're going to do is we're going to apply our definition of arcsine. So it's sine inverse 0.6 plus 360 degrees n. And then what mode does your calculator need to be in? We're just guessing. It is one of those. It's degrees. If this was in radians, what would this be instead of 360? 2 pi. All right, please. I know somebody's going to do it, but don't mess that up on a test or a quiz. It's the worst way to miss a problem. It's really frustrating. And then you're going to get even worse because starting on Friday, we're going to have another mode for our calculator. We're going to look at parametric mode. So we have 3 modes we have to deal with. All right, so now it's just a calculator problem. I start putting in values of n. Oops, in a second. This is my other piece, right? Pi, or 180 degrees, minus this whole thing. And now I evaluate. I plug in values for n. So I approximated that with my calculator. And I put in values for n. With n is 0, I get out 36.9. When n is 1, I get out 396.9. Is that a valid solution? No. Because I'm only looking in the interval to 360. So that one's no good. So can I stop with that one? I can. No other value of n is going to work. And I plug in values of n to the next one. Plug in 0. 143.1 because I take 180 minus this. If I plug in 1, I'm already too big. So the only 2 numbers that work within this interval is 36.9 and 143.1 degrees.